Okay, so here's a little bit more. Chapter 17, help. I didn't want to put them all on the same YouTube video, so I'm breaking them up a little bit. So on this one, we want to verify the micrograms per minute dosage of a drotricogen alpha infusion running at 7.6 milliliters per hour. The IV bag contains 40 milligrams in 250 milliliters of normal saline. What is so we're solving for micrograms per minute, and again we're going to round to the 10th. So for this one, we're going to start out with micrograms. So we're looking up here at our information, and we don't have micrograms, but we do have milligrams. So we need to go from micrograms to milligrams, and this is where a known variable is going to come in. So we know that 1,000 micrograms is equivalent to 1 milligram. If this is milligrams, this has to be milligrams. So that's where we're going to plug in our 40 milligrams in 250 milliliters. If this is milliliters, milliliters has to come next. So we have our 7.6 milliliters over hour. And we know that we don't want to stop at hours. So if this is hours, this has to be hours going to minutes. And our known variable here is 1 hour is equivalent to 60 minutes. So for this one, we have 1,000 times 40 times 7.6. And that gives us 304,000 over 250 times 60 over 15,000. So 304,000 divided by 15,000 gives us 20.26 repeating. And again, we're going to go to the 10th, so we have a 6 here, so that's going to be 20.3 micrograms per minute is our answer for that one. Alright, and the next one here, lots of question here, but don't be scared. So the provider writes an order to start a dopamine drip at 5 micrograms per kilogram per minute. The dopamine drip is to be titrated in 5 microgram per kilogram per minute increments up to, so this is going to be our high dose, so up to 20 micrograms per kilogram per minute. To keep the patient's systolic blood pressure greater than 110 millimeters of mercury. The patient weighs 73 kilograms. The pharmacy supplies the medication in an infusion bag containing 800 milligrams of dopamine in 500 milliliters of D5W, and now we want to calculate our milliliters per hour. Flow rate range at the beginning flow, which is going to be our 5 mics, so beginning, and the maximum flow rate. So that's going to be this 20 maximum flow rate. For the dopamine drip, so round to the nearest 10th again. So again, anytime I'm doing anything with kilograms, I always get my kilograms out of the way. So I'm going to multiply my kilograms by our starting infusion, so 73 kilograms. And then I'm also going to multiply my weight by my maximum infusion. So I'm going to multiply that by my weight as well. So 5 times 73 gives us 365 micrograms per minute, and then that's our first part, so that's what we're going to start out with our dopamine. And then let's do 20 times 73 gives us 1460 micrograms per minute. So now we want to solve for milliliters per hour based on our lowest dose that we're going to start it out and our highest dose. So here I'm going to have milliliters on top for the first part. So of that, we have 500 milliliters, which is here, over 800 milligrams. If this is milligrams, milligrams has to come next. Well, of our other information that we have, because we don't need to use this anymore, so we can mark all of that out. So now we're left with this, this, and this. So we'll see that we have micrograms. So we need to go from milligrams to micrograms. And again, whoops, go back to your known variables. We know that 1 milligram equals or is equivalent to 1,000 micrograms. If this is micrograms, micrograms has to come next. So we're going to solve for our first one. So I'm going to put 365 micrograms per minute, because that's what goes there. And we know that we're not solving for minutes. We need to go to hours. So minutes to hours. We know that there are 60 minutes in 1 hour. And I'm going to go ahead and fill out my next part of this before I do my math. So still yet solving for milliliters per hour. So I'm going to start out with milliliters. So I'm going to put the same information here. So 500 milliliters over 800 milligrams. And again, this is milligrams. This has to be milligrams. And we're going to micrograms. So I'm going to put 1 milligram is equivalent to 1,000 micrograms. And in this case, so micrograms here, I'm going to put in our maximum dose range, which is the 1460 micrograms per minute. And again, we're solving for hours, so we need to go from minutes to hours. So 60 minutes is to 1 hour. So now I have my two ranges. So I'm going to do 500 times 365 times 60. And that gives me 10,950,000 over 800 times 1,000, 800,000. So 10,950 divided by 800,000 gives us 13.6875, which again we're rounding to the 10th, so this is going to be, since this is 8, this has to go up 1, so 13.7 micrograms per minute. And now let's figure out our maximum micrograms per minute. So 500 times 1460 times 60 gives us 43,800,000 over 800 times 1,000. That's still going to be 800,000. So 43,800,000 divided by 800,000 gives us 54.75. Again, rounding that to the 10th, that's a 5, so this one has to go up by 1, so that would be 54.8 micrograms per minute. So our low or starting dose is 13.7 micrograms per minute, and then our maximum dose is 54.8 micrograms per minute. And then I have one last one that I'll do. And this one's very similar to the one we just did. But the patient is receiving nitroprusside IV drip. The prescribed range of the nitroprusside for the patient is 1 to 8 micrograms per kilogram per minute. The patient weighs 87 kilograms. The IV bag contains 50 milligrams of nitroprusside in 250 milliliters. The IV is currently infusing at 38.7 milliliters per hour, and we want to calculate, so how much micrograms per minute dosage that is currently infusing, so that's going to be with this one, and then rounding the final answer to the nearest tenth. And then after that, we want to determine if it is within or outside the range. Whoops, outside the range. All right, so again, anytime we have a question with kilograms in it, I go ahead and get that kilograms out. So in this case, I'm going to do my 1, which is 1 micrograms per minute, and then my 8 micrograms per minute. So I'm going to multiply both of these by 87 kilograms to figure out our range for our dosage. So 1 obviously times 87 gives us 87 micrograms per minute, because we took that kilograms out, and then my 8 times 87 gives us 696 micrograms per minute. So now again, this is our range for our medication. So that's all we're going to do with those, and once we get our answer for our micrograms per minute on what the patient's actually getting, we're going to compare that number and see if it falls within the range. Alright, so we're solving for micrograms per minute. So I need to start out with micrograms. So of our information now that we're going to be using, which is this and this, we see that we have milligrams. So we need to go from micrograms to milligrams. So we know that variable is 1,000 micrograms is equivalent to 1 milligram. If this is milligrams, milligrams has to come next. So that's where we're going to plug in our 50 milligrams in our 250 milliliters. If that's milliliters, milliliters comes next. We're going to plug in our 38.7 milliliters per hour. And we know that hours is not where we're going to stop, so we need to put 1 hour, is to 60 minutes. And minutes is where we need to end up, so that's going to be it. So then our milligrams cancel out, our milliliters cancel out, and our hours will cancel out. So 1,000 times 50 times 38.7 gives us 1,935,000. And then we'll do 250 times 60, which gives us 15,000. So let me divide those. 1,935,000 divided by 15,000 gives us 129 micrograms per minute. So this is our answer, solving for our micrograms per minute, and now we need to find out if it is safe and therapeutic, or if it is within our prescribed range, and we go back and compare here. So 129 is 129 in between 87 micrograms and 696 micrograms, and yes, it is, so it is within range. And so that is that answer.